Ilara lay on the grassy hill, her head pillowed on her backpack, gazing up at the endless blue canvas above. It was a perfect, cloudless day, and the sky was a brilliant, uniform blue. Why blue? She whispered to a passing ladybug. Of all the colors in the world, why is the sky always blue? Her question hung in the air until a gentle voice answered. That is one of the universe's most beautiful questions. Ilara sat up to see an old man with a kind smile and a telescope pin on his lapel. He introduced himself as Dr. Eris, an astronomer. The answer, he said, is a story about light, air, and a little bit of magic we call physics. Dr. Eris took a small crystal prism from his pocket. Sunlight, which we see as white, is actually a secret rainbow, he explained, holding the prism up. As the sunlight passed through, it fractured into a brilliant spectrum of red, orange, yellow, green, blue, and violet on the grass. Each color is a light wave, traveling with its own special energy. Imagine light waves as runners in a race, Dr. Eris continued. Red and orange are long, loping strides, while blue and violet are short, quick steps. He sketched in the air with his finger. These waves travel from the sun, 93 million miles away, to reach our eyes. But before they reach us, they have to get through our atmosphere, said Dr. Eris. Think of the atmosphere as a giant obstacle course made of invisible, tiny particles, mostly nitrogen and oxygen molecules. It's a busy, crowded place up there. Now, when the light waves enter this obstacle course, the long, red waves just stroll right past the molecules. But the short, energetic blue waves are a different story. They are just the right size to bump into the air molecules. When a blue light wave hits an air molecule, Dr. Eris's eyes twinkled. The molecule absorbs it for a split second and then flings it out in a completely new direction. This is called Rayleigh scattering. The blue light is scattered everywhere, up, down, and all around. So when you look up, he concluded, you aren't seeing the sky itself as blue. You are seeing countless blue light waves that have been scattered by the air molecules and are now bouncing down into your eyes from every direction. The whole sky is glowing with scattered blue light. But what about sunsets? Ilara asked. Why are they red and orange? An excellent question. Dr. Eris beamed. At sunset, the sun's light has to travel through much more of the atmosphere to reach you. By the time it gets to your eyes, most of the blue light has already been scattered away, leaving the longer waves of red and orange to paint the sky. Ilara looked up at the sky again, but this time it wasn't just a color. It was a story of light waves on an incredible journey, a dance of scattering particles, and the beautiful physics that painted her world. The blue wasn't just a color. It was the signature of sunlight's grand adventure.